The intermediate value theorem in calculus states, if f is continuous on the closed interval a, b, and k is any number between f of a and f of b, there is at least one number c in the closed interval a, b, such that f of c equals k. Let's look at what this means on a graph. So here we have a closed interval from a to b in the graph at the left. The intermediate value theorem tells us that as long as this function is a continuous function, we are guaranteed that there is some c value in between a and b such that f of c equals k. Now, the function has to be continuous, and as long as the function is continuous, we are guaranteed that the function hits every single intermediate value in between f of a and f of b. If we look over here at the graph to the right, we see that the function is not continuous. Therefore, we are not guaranteed that the function hits every intermediate value between f of a and f of b. So in this case, the intermediate value theorem would not apply. The intermediate value theorem is one of the existence theorems in calculus. It doesn't tell us what the c value is, just whether we are guaranteed that a c value exists. To learn about another existence theorem called the mean value theorem in calculus, click this video to watch that. Let's look at some typical calculus examples where the intermediate value theorem would show up. In this problem, it says to use the intermediate value theorem to verify that f of c equals 10 for some c value in the closed interval 3, 6 if f of x equals x squared minus 6x plus 15. Well, the first thing we have to determine in order to even use the intermediate value theorem is that the function is continuous on the closed interval. In this case, f of x is a polynomial function. Therefore, f of x is continuous on the closed interval 3, 6. That is the only thing that has to be true in order to be able to apply the intermediate value theorem. So now we know we can apply that. Now the problem said to use the intermediate value theorem, but let's say it did not even say that. We know to use the intermediate value theorem when we are looking to see whether a certain function value exists. In this case, whether f of c does equal 10. All right, what we need to do is we need to find f of a, which in our case is f of 3. Plugging in 3 into this function, 3 squared minus 6 times 3 plus 15 gives us 6. Now we need to find f of 6. Plugging in 6 into this function, 6 squared minus 6 times 6 plus 15 gives us 15. All right, so f of 3 equals 6. F of 6 equals 15. We are guaranteed, because the function is continuous, that that graph will cross through every intermediate value between 6 and 15, which includes the value of 10. So back to our justification, since f of x is continuous on 3, 6, okay, we are guaranteed there is a value c in the closed interval 3 to 6 such that f of c equals 10 because our value of f of 3, which was 6, is less than 10, and 10 is less than f of 6. If you're finding this video useful, make sure to click subscribe right now so that you're notified when new calculus videos come out. Let's look at one more typical example we would see in calculus using the intermediate value theorem, and this one uses a table. So it says a car travels on a straight track. During the time interval from 0 to 60, notice a closed interval, in 0 to 60 seconds, the car's velocity v, measured in feet per second, is a continuous function. That's going to be really important in order to be able to use the intermediate value theorem. The table below shows selected values of v. For t values between 0 and 60, must there be a time t when the velocity is equal to -5? Justify your answer. Okay, this time it doesn't say which theorem to use, but because we are looking for a specific function value, in this case, whether the velocity is -5, we know to use the intermediate value theorem. The first thing it's important to note is v of t is continuous on the closed interval from 0 to 60 because we are told that velocity is a continuous function. All right, so are we guaranteed that there is a velocity value of -5? Yes, because we can see right here that -5 would fall between those y values. And because the function is continuous, we know it hits every intermediate value in between those two y values. So, since -10 is less than, you know what, in fact, instead of -10, I'm going to say since v of 35, all right, which is -10, is less than -5, and -5 is less than v of 50, we are guaranteed there is a time t, a time not in, but a time t now in the closed interval 0 to 60, such that the velocity does reach -5. Again, I hope you found this video useful to learn about the Intermediate Value Theorem, which is one of the existence theorems in calculus. Make sure to subscribe so that you're notified when new videos come out that will help you in your math classes.